I'm going to quickly run through the t-test again, and this time I'm just going to look at the main outcome variable, which is hand grip strength over the two conditions. So the same as what I did in the previous video, I'll just whip through it all a bit faster. So again, I will start off by doing some plots to check some of those main assumptions. So first of all, I'm going to have a look at the box plot and see if there's any outliers. We're interested in hand strength and over the two conditions. And this time we can see that it looks like there is a difference in the variation between the two groups. So there's less variation here in the condition group than there is in the control group, except that we do have this outlier. Now, this particular person appears to be stronger than everybody else in the study, and they do say in the paper that they have excluded him. Now, we can't just exclude data because it messes up our results. However, if you do have a valid reason for believing that one particular person is unusual in some way and perhaps doesn't meet the requirements of the study, so if we have an unusually fit person, perhaps they were either in an occupation which required an excessive amount of hand strength, or even a bodybuilder or something. So perhaps if the person was unusual in some way and we're interested only in the effects of the age comparison on what we might call regular people, then that would be a valid reason for excluding them. In any case, having this outlier here will have the effect of pulling up the mean of this group. And so this would be of concern. It's possible at this point that you might want to use a non-parametric test. However, because the paper has excluded this person, I'm going to assume that there was something unusual about them, and I will also exclude them. Before I do that, I might just go ahead and look at the graph of the normal distribution to see if there's anything else of interest. Sorry, not with that one. I'll go back to the legacy dialogues and the histogram. And I'm not interested in age now. I'm actually interested in our main outcome, which was hand grip strength, and I still want the normal curves. So again, not completely normal. With the small sample sizes, I'm not too worried. And we do have this effect of chopping off or truncating at 0 just because you can't score less than 0 on this particular test. So the data is not completely normal. However, I personally don't think that the problems with it are severe enough that I think it would affect the outcome of the test, except for this one person. So to do what the authors have done and to exclude him from the study, you may have noticed that in the data set, now I think this came through on the data set and not something I added, there's what we call a filter variable. So we can ask SPSS to exclude people based on something else, and you can see that everyone else has got a 1 except for this person who's got a 0. And they had the hand strength of 34, which is really high. So to do that, we go to data, select cases, and I've got a filter variable, so I'm going to use this. You can set up your own filter based on a condition if you want to. And we're just going to filter out the unselected cases. And we get a little note here. So if we just want to check that that's worked, we can probably go ahead and redo that box plot. And we can see that it's worked because we're not getting that outlier anymore. So now when we run this test, any conclusions that we draw are based on the fact that we're not including this person. So if you did have particularly strong people that you weren't including, then the conclusions are watered down because it's based only on the other people. Run the test, we go to compare means, we've still got independent samples and a t-test. Not interested in age anymore, we'll put in the strength. Conditions are the same. Okay. So now when we look at the, I guess we can look at the group statistics first, and already we can see there's quite a difference in the means. So the average hand grip strength, I believe that's in kilograms, 6.9 for the condition group, where they were given that trigger of being compared with younger people. And then in the control group, the mean is much higher at 11. So it feels like there's quite a difference there, and that's what we're testing. The test for the equality of variances, so it does look like in these graphs that there is less variation in this group than there is in the other. The null hypothesis is that the variances are equal. We've got very strong evidence against that hypothesis, and therefore we will assume the variances are not equal. So that means we're using the second version of the test. Now, if you get this wrong, it's really not a huge problem. Often you'll find that the results are pretty similar anyway. So the null hypothesis for the t-test is that the means are equal. We have a p-value of 0.04, which is less than our traditional cutoff of 0.05. So we would say here that we've got good evidence against the null hypothesis, and there is an effect of this age-related comparison in reducing hand grip strength. We also get an estimate of the difference, and this is quite important. You usually need to report on either the mean difference or convert this into some kind of effect size, which I'm not covering here. So what this tells us is that on average, the people who were in that age-related comparison group were able to grip about 4 kilos less than the control group. So I don't really know a lot about hand grip strength, but this seems like a pretty big drop to me. And we have a confidence interval around that. And note that the confidence interval is quite wide, going from -8 to -0.2, and that's most likely due to the sample size being relatively small. So perhaps if this was repeated and they doubled the sample size, we would find a similar effect, but perhaps the confidence intervals would tighten up a bit. So that would be an interesting thing to do, to replicate this with more people. So the last thing we might want to do is show these results in a plot of the mean and the confidence interval. So if you remember the paper, they do have a graph here of the mean hand grip strength in the two groups. Now, I personally don't like the use of bar charts for showing means. I feel it's confusing, but they do have this confidence interval here. In any case, when you do this in SPSS, it will by default give you a different plot. So if we go into Chart Builder and look at our error bar chart under bar, by default you'll just get a dot for the mean instead of a bar, and I think this is a good idea just because it's a little bit less confusing than using bar charts for two different reasons. So here we can see that the mean for the Group 1, which was the age-related comparison, is quite a lot lower than Group 2. There is an overlap in the confidence intervals, and so when you see an overlap like this, you really do have to do the test to get the p-value out, because you can have an overlap in the confidence intervals and still get a significant result. If there is no overlap in the confidence intervals, you will definitely get a significant result. So if there's no overlap in the confidence interval, the result is really clear. If there is some overlap, you need to actually get the p-value out just to check whether or not that's significant. And of course, I would change the colour on that graph if I was actually going to use it in a report.